So in this example, this is exam review 3, question number 10. And this says, use the right-hand rule to show the directions of the magnetic force on a charge moving in a magnetic field. Draw all three vectors. So part A says you have a magnetic field coming out of the board. So here's our magnetic field coming out of the board. So we use a dot to represent that magnetic field. I'll put a B vector in a sec. And we're told a positive charge is moving to the right in that direction. So we have the velocity vector v. It's a positive charge, so it's a positive charge. And the magnetic field B is coming out of the board. And I shouldn't have done that. I should put a diagonal here, B vector. And so the question is, what's the direction of the force? So again, first thing you should be writing is what's the equation that we have to write? It's F is equal to Q, V, cross, and B. And if you should have watched the video for the right-hand rule in my notes. So if you watched the notes, or you came to class, actually, it'd be nicer. So QV cross B. So the velocity vector is this. We have the magnetic field going towards you. So I have to turn V into B like this. So V cross B. I want to find the direction of V cross B. So I take my right-hand rule, and so I have to turn this way, right? So my thumb points in the bottom direction, and so this means that the force is acting down. And it's a positive particle, so V cross B is pointing down, and then positive times pointing down is still pointing down. So it's actually a force down. So part A says that if you have a magnetic field that's coming out of the board and the positive particle is traveling velocity v, and then the force is pulling down. Okay. So the next part, right, is that we have another example. B, we have a magnetic field going to the left in the plane of the paper and a positive charge. We have a magnetic field going to the left. So again, it's a positive charge. It's a positive charge. So we have a magnetic field. So I'll put this B this way. So here is our B field. Magnetic field is going to the left in the plane of the paper, and as a positive charge is moving out of the paper. So here is dot. Here's our velocity vector. I'll put it on the side over here. It's positive. So again, first thing you should be writing is just look at the equation. F is equal to Q, V cross B. Make sure you look at that equation. It's not B cross V. The force is given by, the magnetic force is given by QV cross B. So what is the direction of the force? So let's take a look at it. So VQ is positive, but let's calculate the direction of V cross B. So V is coming towards you. Here is the magnetic field B, and so V has to be turned into B like this. V has to be turned into B. And if I do, this rule says this way. V turns into B with my finger pointing down. And so the force, the V cross B direction is actually coming straight down. Okay. And since Q is positive, then the direction of force is in the same direction, so we're expecting V cross B scaled by a factor Q to get the force of the magnetic field. So it's going down as the force. So the force on the particle is pointing down. Okay, so part C, right, is basically the same question, but now the question is, we have a negative charge. We have a negative charge. Okay, so negative charge. Notice that the particle is traveling velocity v, and v cross b, it doesn't change. V is still the same this way, b is this way, v cross b is right-hand rule, it's pointing down, so v cross b is still pointing down. But Q is negative, and so you're actually saying that whatever the force is, this is scaled by a negative value of this vector, which means that the force must be pointing in the opposite direction. So it's perpendicular to both V and B, but it's in the opposite direction, scaled by a negative Q of V cross B. V cross B is scaled by a factor of negative Q. So the force on a negative charge traveling this way in a magnetic field B will experience a force up, while its positive charge will experience a force down. I think that should be enough.